All right. Recall that a solution of a differential equation is a function that satisfies the equation, meaning that if you substitute it as y, then you get a correct equality. So, but the equation has the left-hand side and the right-hand side. So, if a function satisfies the equation, then at least the left-hand side should make sense. So, y prime should be something meaningful. So, which means that y has to be differentiable. And the right-hand side must also make sense, meaning that if you substitute t and y of t into f, then you must be able to calculate the value. So, which means that the point t belongs to the domain of the function f. So, and another thing is that what we discussed earlier is that a differential equation sort of describes a motion, continuous motion, and which means that the domain of a solution is always required to be an interval. So here is the definition. So a first order differential equation is the following expression. So y prime equals f of ty. So f is supposed to be a function of two variables, and it is supposed to be defined on an open set. So usually, I know that previously we considered some cases when the domain is not necessarily an open set, but because of some reason it is more convenient to work with open sets. Here you will see it after the application exercises in the next week. Also, it is convenient to assume, although strictly speaking it is not necessary to assume, but it is convenient to assume that f has continuous partial derivatives, or in other words, f must be a continuously differentiable function on its domain. And again, because of some technical reasons, I don't want to go into details, but it's very easy to remember. Then a solution of this differential equation is a differentiable function. Its domain is an interval, and besides, it must so the point t and y of t must belong to the domain of the right-hand side of the differential equation, and of course the solution must satisfy the differential equation.